Alright, so as we start Unit 8, which is going to be about right triangles, we need to just review a little bit of algebra skills before we do that, okay? So what we're going to do is we're going to talk about squaring radicals. So remember, when we square a number like 3, we're going to multiply 3 by itself, and 3 times 3 is 9, okay? And then remember that a radical is any number that's underneath this square, or it's just a number underneath a square root bar. Okay, so we're talking about the square root of, in example 1, 13. Okay. Now, when I take the square root of 13 squared, I'm going to go and multiply the square root of 13 by itself. There's a rule that says when you have two radicals multiplied by each other, I can multiply the insides and put them underneath 1. So 13 times 13 is 169. And now we know the square root of 169 is 13, and we're done. Okay? Let's look at example 2. I have the square root of 20 squared, so that means it's root 20 times itself. I can combine them together again. 20 times 20 is 400, and the square root of 400 is 20. Now, if we look at examples 1 and 2, something that you might notice is at both times the answer that we got was the same as that number that was underneath the square root. Okay? So we can generalize this idea and say that a square root and a square are inverses of each other, and those are actually going to cancel each other out, and you're going to be left with the number inside. So the square root of 789 squared, they cancel the root and the square, and we're left with just 789. So it turns into a really quick problem, actually. All right? But now, in example 4, we've made this a little bit more complicated, all right? I have not only the square root squared, but there's now a number in front. So this says, what is 3 root 4 squared? And if we use our exponent properties from Algebra 1, I know that that squared has to go both to the 3 and to the root 4. So I'm going to rewrite this as 3 squared times root 4 squared. Okay? And then we're going to continue. I know that 3 squared is 9. And then I know that the square and the radical are going to cancel. And I'm just going to be left with the number that's inside, which is 4. And then I can do 9 times 4, which gets me 36, and I'm done. All right, let's look at example number 5. I'm going to distribute the square to both terms inside the parentheses and write that as 4 squared times root 2 squared. I'm going to recognize that 4 squared is 16. The square root and the square cancel. I'm left with just 2. And I'm going to do 16 times 2 and get 32, and I'm done. If you want to pause the video now and try number 6 on your own, please do that. All right, and if you did it correctly, check your work. You should have gotten 21. If not, make sure that you look at the solution and fix your mistake. All right? And then we will move on to topic number 2. So topic number 2 is about the Pythagorean theorem, and we've actually seen this before in our class when we were learning distance on the coordinate grid. So part of this might be review for some of you. So if remember, the Pythagorean theorem says that c squared equals a squared plus b squared. We're going to use this every single day during this unit and through the rest of the year. So the Pythagorean theorem only works on right triangles, so I have to make sure I always have that right angle in the triangle that I'm working with. And remember that the side across from the right angle, we call that the hypotenuse, and then the other two sides are called the legs. Okay? So when I'm looking at example number 1, it says to solve for x. I have a right triangle, so I know I can use the Pythagorean theorem. The first thing that I would do for every single problem is identify the hypotenuse. It's across from the right angle, so I know that x is going to be my c value. I can use the Pythagorean theorem. Let's just rewrite it. C squared equals a squared plus b squared. Right? C squared is, I know, or c was x, so I know that's x squared equals And now A and B don't necessarily matter. I don't care if 6 represents A or B. That's interchangeable. So I'm just going to pick 6 squared plus 8 squared, and then we can work from there. The first step is to square both of these. So 6 squared is 36. 8 squared is, 64. And now in this example, I'm going to combine these two together and add them. So I get x squared equals, I think that's going to end up being 100. And then similarly to topic number 1, at this very last step, I have x squared equaling 100. Well, what undoes a square? A square root. So I'm going to take the square root of both sides, and I know that now x has to be, right, those end up canceling. I'm just left with x, and the square root of 100 is 10. And now what you want to make sure is that you keep your units in every single answer if we have them. So if this says 6 inches, 8 inches, this answer is now 10 inches, and I'm done. Okay? Let's look at example 2. I have a right triangle. Here's my hypotenuse across. I'm going to label that C. And I'm going to use the Pythagorean theorem to solve for x. C squared equals a squared plus b squared. C is now 17 squared equals, a and b are interchangeable, so I'm just going to do 15 squared plus x squared. The first step here is the same. I'm still going to square. 17 squared is 289, and 15 squared is 225, and I'm going to add the x squared. Now this is the different step from example number 1. At this point, you actually want to subtract 225 from both sides because they're on different sides of the equal sign, okay? When I do 289 minus 225, I believe I get 64. That equals x squared. And then at this point, it's exactly like example number 1. I take the square root of both sides, keep my colors the same, square root of both sides, and I believe that the square root of 64 is 8, and the square root of x squared is just x. And do we have units here? Yes, so I'm going to add in 8 centimeters there. Okay? All right, now let's look at example 3 and 3. There's a typo there. It should be 3 and 4. Okay? So, again, I have a right triangle here, so I'm going to identify the hypotenuse, C, and let's set up the Pythagorean theorem. C squared equals a squared plus b squared. Okay? So now that I know that the hypotenuse is 7, I know that it's 7 squared equals, and it doesn't matter, I could do 3 squared plus x squared, or x squared plus 3 squared. 7 squared is 49, 3 squared is 9, plus x squared, just like before. Let's take away 9 from both sides, like example 2, and I get 40 equals x squared. And I'm also going to then square root, just like we did before. And now this is where it gets a little bit tricky. In examples 1 and 2, when we got to this step here, we actually knew the square root, okay? But this time, the square root of 40 is not nice. It's not a perfect square. So there's going to be 2 different types of answers you have here. There's going to be the exact answer, and then there's going to be the estimated answer. Okay? Another word that I could have used here is like the approximate. Either of those mean the same thing. Okay? So the exact answer means, okay, that's not a perfect square. I don't know that off the top of my head, the square root of 40. So I'm going to leave that underneath the radical. X equals the square root of 40. Okay? And then I have the estimated answer. And what I mean by the estimated answer is a decimal approximation. So I'm going to say x is approximately, and I'm going to actually plug it into my calculator, and I get 6.32. Let's always round to 2 decimal places unless the problem says otherwise, okay? So I have the exact includes the radical, and the estimated is a decimal, and those are my 2 different answers, okay? Now in example number 4, I'm just going to separate this a little bit to make our lives a little easier. I'm actually going to combine topic 1 with topic number 2. Okay, so we're still going to start the same way. Find my right angle, here's my hypotenuse, and let's use the Pythagorean theorem. I'm going to plug it in right away. We know it's c squared, c is 6 squared, equals, a and b are interchangeable, x squared plus 3 root 3 squared. Okay? Now, the nice part is over here. 6 squared is 36, and x squared we know. But 3 root 3 squared is a little bit more complicated. So I'm actually going to take a second and solve what is 3 root 3 squared above. So 3 root 3 squared, if we remember, the square distributes to both, and I'm left with 3 squared and root 3 squared. Now 3 squared is 9. And what happens with a radical and a square? Those cancel, and I'm left with the number inside. So that's just 9 times 3, and 9 times 3 is 27. So now I know, and I can plug back into my Pythagorean theorem, that 3 root 3 squared ended up giving me 27. And we can solve from there, just like we did. Subtract 27 from both sides. I believe that gets you 9 equals x squared. Take the square root, like we did before, and I get that 3 equals x, but we need our units. YD, if you didn't know that, is yards. So this is 3 yards, and that's what x is going to equal. All right, you're ready to go practice in class or to complete your homework, and I hope you have a great night or day.